Hello, algebra students. Well, today we're looking at multiplying radical expressions. So radical expressions can have variables. So we've looked at multiplying radicals, but they were numbers, but they did not have variables. So these that we're going to do today, some of them will have variables. So a quick review of the product property for multiplying radicals, and we use this same property when multiplying radical expressions that have variables. So first of all, as it says here, the index must be the same to multiply them together. Okay, they have to have the same index. And here are the steps. Multiply the coefficients, then multiply the radicands, and then simplify by cake if necessary. And these examples just are just numbers, okay, without the variables. And those are the steps we use. So let's go ahead and do these real quickly. So simplify this. The index is the same on this one. So there's nothing outside, so we multiply the radicands. And so inside we get 4 times 2, which is 8. So we have the cube root of 8. And we might be aware of what that is, but if you're not, we can do a little cake here. Divide by 2, get 4. Divide that by 2 and get 2. Divide that by 2, and that's it. So it's the index is 3, so we're looking for groups of 3, right? And yes, we do have a single group of 3 there, which is a group of 3 2's, so we pull out 2. And there's nothing that goes in. There's nothing left over. Okay, so that's the answer, just 2. Okay, look at this next one. So they do not have the same index. See, this has an index of 3, and the second one has the index of 2. Remember, when the index is not written, then it's understood to be 2. So they don't have the same index, so they cannot be multiplied. So that is your answer. If you have any like that, just write down cannot be multiplied. Okay, look at the next one. These are both fifth root, so they can be multiplied. So get the fifth root of, and we multiply those together. Negative 5 times negative 2. Okay, negative times negative is a positive, so it's 10. So we can see if we can simplify that, and by cake, and you need groups of 5, right? So we're pretty sure we're not going to have any group of 5 out of that, but we could go ahead and do the drill anyway. Divide by 5, and that's it. So all we have is this 2 and 5. We don't have any groups of 5, and so we don't pull anything out, and so this is the answer, just like that. Okay, nothing to pull out of the radical, so it just stays inside. Everything stays inside. It's 10. Okay, so now we will look at multiplying radicals with variables. So the rules that we follow are similar to what we did if they don't have variables. Okay, we multiply the coefficients, and I mean by that coefficients of the radical, the number outside the radical. So some of them have a number outside. And I'm not talking about the index, of course, not talking about that, but we're talking about a number that's outside that's multiplied by the radical. So each of the radicals may have a number out there, so multiply those. Multiply the radicands, including numbers, whatever numbers and or variables that are in there, okay? And add exponents on like variables when multiplying. That's just the rule for multiplying monomials anyway, so that's just a reminder. When you multiply them, add exponents on like variables, and then cake to simplify. Okay, so let's look at this first one. There's no numbers outside, so we just multiply those radicands, everything in there. And in the process of that, we will be adding exponents on like variables. So we have 45 times, there is no number in the other radical. So 45 is all there is. So now we need to multiply everything else inside the radical and add the exponents on like variables. So we have this x to the fifth in this one, and over here is x to the first. So we just add those exponents. So it's x to the sixth. And then for the y, we have y to the fourth, y to the third, and y to the fourth. So that's y to the seventh. And then we cake to simplify. Well, we know we can simplify that 45, right? We can squeeze that in here. So we go with 3, and that gives us 15. 3 again, that gives us 5. And this is a square root we're doing, so this group of 3 is the 1. Okay, and I actually wrote that in just the wrong place. Yeah, we can just move it over. Just take a second here. We lasso it. Move it out of the way. Put it up here. Okay. So for the 45 will be so I took care of all the other variables, right? Okay. So we have, and that somehow I managed to erase that. This is, I don't know what happened here. Let me fix this. Okay, so we added the exponents on the like variables. That's how we got x to the sixth and x and y to the seventh inside the radical. Okay, so what comes out is the 3, right? So we take a 3 out of the radical, and and 5 will remain inside, right? But we need to take more than just the 3 out. We also have variables we can take out. Okay, so we have x to the sixth, and so we could write that down like this. Let's go ahead and do that on this one. So we're looking for groups of 2 there as well, right? And we have y to the seventh. and our groups of 2 there. And I know from grading you guys papers that you're not always doing this. You know, you can do this mentally as well as writing it down, but I'm just going to write it down to show everything that we've got. And I just realized I need to write this down below. This one is really squeezed in here. Okay. So that equals, we bring out the 3, and we bring out also, we have 3 groups of x, so that's x to the 3rd power, right? And for y, we have 3 groups of the y, so that's y to the 3rd power. And inside, we still have the 5 and y, like that. Okay. Three times x cubed times y cubed, and inside 5y. Okay, let's look at the next one. So there's again nothing outside to multiply, so we multiply the radicands, including the numbers. Okay, so that is square root of 25b to what power? Add the exponents, right? So 3 plus 3 is 6. That's all inside. Okay, and now we know what this is going to be. I think we know the square root of 25. I mean, we could cake it. Do that right here. Get 5. And, well, just have to divide that by 5, of course. So, yeah, we've got a group 2 5s, just like we knew we would. And so a 5 comes outside. In the b's, we're going to have 3 groups of 2 with those 6, right? So that's b to the 3rd power. And nothing left inside as far as the b's, okay? No numbers left inside, and no b, no variable left inside the radical either, so there is no radical. Okay, the next one, and it does have the same index, so we can multiply it, but they both have the index of 3. So we have cube root of, we multiply 20 times 15. Okay, 20 times 15 is 300. And then we multiply the variables, so that's y to the 8th, right? Add exponents. 4 plus 4 is 8. Okay, so this is the cube root. We'll cake that 300. Do that right here. So we'll start with 2 and get 150. Do 2 again. We get 75. Then we'll go with 3, and that gives us 25, and then 5, that gives us a 5, and that's it. So these are cube roots. So we are looking for groups of 3, right? Well, we have groups of 2, we have a couple of 2s, we have a couple of 5s. We don't have any groups of 3 though, so we will not pull any numbers out. Okay, we needed groups of 3 to do that. So what about the variables? Do we have groups of 3 when we have 8 of these y's? Yeah, there's 2 groups of 3, and that would leave 2 left over, right? If we pull out 2 groups of 3. So since we have 2 groups of 3, it's y squared on the outside. On the inside, we'll have some y's left over as well, right? We'll have y squared inside as well, because when we have those 2 groups of 3, that makes 6, and there's still 2 left. So that stays inside along with the 300. The entire number 300 stays in because we did not bring out any primes when we did the cake. So all the numbers stay inside, so the 300 stays inside, but we do have also that y squared inside because of those two y's that are left over. Okay, so just one more. That's all we could fit on one page. I need to save that. Get the other page brought in here. And okay, so this is the last one we're going to look at. It does have numbers on the outside, so none of the others we did had that. So we multiply the numbers on the outside. 4 times 5 is 20. We multiply what's on the inside, including variables. So 2 times 6, that's 12. And then for x, we have, each of those has an exponent of 1, right? So we add those to get exponents, we get 2. And for y, well, we just have the single y here, y squared. So that's our exponent there, it's y squared. So now we have to do the cake on the inside. 12, we probably know, or we'll remember, we'll get it here shortly. So that's it. We do have a group of 2's. So the 2 comes out, and that's 2 times 20, so that's 40 on the outside, right? Okay, on the inside, we're going to have the 3. We also need to bring out x, sorry. So we bring a 2 out, and that gives us 40. What about the variables? So we're looking for groups of 2, and we have x times x, right? X squared. So that's a single group of 2. So out comes an x. With y, similarly, we have a single group of 2 y's. So since it's only one group, we bring out the other y. There's no leftovers in the variables, right? We're looking for groups of 2, and we had just one group of 2 x's, one group of 2 y's, but nothing left over. So the only thing that we have left over is that 3. So that goes in the radical. Okay. I'm actually going to make this look a little bit better. I made that too big. Okay, so that's it for that one. Once you multiply them, and once you multiply everything outside and everything inside, it's just, we simplify them, okay, the same way we did the other day on the homework. That is using the cake method. Okay, that's all for this one. See you later.